So in the next section, it's talking about designing experiments, and this is pretty interesting because you see this so many times. There's two different types of experiments that you can do. There's observational and there's experimental. They're kind of just the way they sound. Observational, you would just kind of observe the people. Or maybe you'd be observing a certain behavior. The only problem with doing this and just watching people and seeing and noting what you see is it's often affected by lurking variables. And I'll talk to you more about that. So lurking variables. Let me give you an example. There's a vitamin D study. They published this vitamin D study that said, that they observed people and got their vitamin D levels measured, and people who had a larger amount in their bloodstream were healthier. And I'm sure they used other terms, had lower risk of heart disease in the future or lower risk of cancer and in general healthier. So lots of doctors were ordering these tests and saying, okay, let's, give vitamin D to everyone because vitamin D makes you healthier. The problem with the study is that there's certain places where you get a lot of vitamin D naturally, and one of them is outdoors. Well, if you think about it, someone could be outdoors a lot because they're walking, or in my case, you're running a lot outdoors. So I'm getting a lot of vitamin D. If you're exercising a lot, of course you're going to be healthier. So they weren't measuring exercise in this study. They were only trying to measure vitamin D. And what was ended up happening was they were getting people who may have been healthier for other reasons than just this vitamin D. Maybe they were doing a lot of work outdoors and was causing them to burn more calories out there and also increase their vitamin D from the sunlight exposure. Maybe they were health conscious people. And they were taking vitamin D supplements already just because it's part of their routine vitamins. But overall, they were health conscious people watching what they were eating. And that's why maybe they were healthier, not necessarily because of the vitamin D. So what this is called confounding. And it's when two variables affect the response. And it's to the point where you can't just separate them. You can't just say, okay, well, let's talk about the people who just have a high vitamin D but don't go outside. Well, it's kind of hard to separate that. Or let's take people who are not health conscious. You can't really separate them. That's what this confounding is that this is like in the experiment and there's no way you can really test the effects of the actual vitamin D. For experimental, this is the preferred way by many. And it's used by medical by scientists, in business. And usually what happens is it's an experiment to test treatment. For example, maybe you want to experiment on a new pill, okay? So your treatment would be giving people pills. And there's always usually a control group who still receives a pill, but will receive like a placebo, which is a pill the same size, same shape, same color, but actually has no active ingredients. And in an experiment, we call the people the animals, or the people that are participating, experimental units. For humans, we usually call them the subjects. So that's the formal way of saying this. And the last thing I want to talk about is in the last chapter, we noted correlation. And even when there was a high correlation, or it was a strong correlation, I remember the correlation ranged from -1 to +1. So even when it was like 0.99 of a correlation, it didn't mean that one thing caused the other. I know that was a missed problem a lot on the test, was people were thinking, well, if it's really strongly related, then one causes the other. That's not always the case. Remember when we were talking about GPA? GPA in high school helped you predict the GPA people would receive in college. And it was a moderately strong correlation, I believe, between those two things. It doesn't mean that people who do well in college or in high school causes them to do well in high school or in college. It doesn't mean that they're caused by one another. It means that they're related, that there's a strong connection between them, but not that one causes the other. There are people who don't do well in high school, yet still manage to do well in college. It's a different environment. There's a lot of other variables that go into play. In a well-run experiment, we might be able to imply causation. We might be able to say, yes, vitamin D does cause you to be healthier. We might be able to do that if the study is really well run, if the experiment is done well. You might be able to say that. And if an observed effect is so large that it's statistically significant, then we can say that one actually caused the other.